Welcome to this video where I'm going to show you everything you need to know to get started building on AWS. AWS, or Amazon Web Services, is a cloud computing platform that gives you the building blocks to make all kinds of software products. This could be something like a simple landing page for yourself or your business. It could be a SaaS application for your startup, and it scales all the way to big commercial products like Airbnb or Netflix. It is currently the most widely used cloud platform by quite a wide margin, which also means that there's going to be a lot of community knowledge and job opportunities available related to AWS. The reason I'm making this video today is because I realized that a lot of tutorials and projects on my channel use AWS technology, but at the same time, I haven't made any content that shows you how to actually get started with it. So today, I'm going to walk you through everything you need to know so that you can get started building on AWS. In this video, we'll cover some basic things like account creation and pricing. I'll quickly walk you through some of the core services available as well. I'll show you how to set up the AWS CLI so that you can interact with your account directly from your terminal. And finally, I'll show you how to set up AWS CDK, which will let you manage your infrastructure with code. First, let's talk a little bit about AWS Services. And you can think of these as the building blocks for your application. There's actually a lot of these available and they do different things. For example, they can run your code for you in this compute section. They can store things for you in the storage section. There's databases, machine learning, and just a whole bunch of stuff. And you don't really need to learn them all to get started. There's only maybe 10 or so core services that you really need to know about. Let's quickly go over some of the main ones. The first one you probably want to know about is EC2. This is your stock standard virtual server. So you can rent these by the hour or per day, or you could just leave it on for the whole year. And you can choose from small servers or big servers, and they will have different pricing. This is good if you have a traditional full stack web service that you want to host. For example, something like a Python Flask application, a Node Express server, or maybe even a WordPress website. Also in the compute category, you also have Lambda, which is probably my favorite AWS service. Lambda lets you run code serverlessly. So you're not actually paying to have a live server running, like with EC2 instances. With Lambda, you just use the function whenever you need it. For example, somebody calls your API or something happens maybe once an hour and you want to run a function. You only pay for that usage by the millisecond. So it turns out to be extremely cheap and extremely scalable. Next, there's a service called S3, which stands for Simple Storage Service. And this is basically just file storage. You can put images, text, video, anything you need stored. Think of it as your AWS version of Dropbox. And unless you're hosting your own database inside an EC2 instance, you're probably going to want to use one of these managed database services. And there's a bunch of different ones here. If you're using SQL, then the most common one is RDS, which is basically your managed SQL database. But if you want a serverless option, like the Lambda function, where you only pay every time you read or write from it and not have to pay to have that instance provisioned, you can use DynamoDB instead, which is a serverless database, kind of like a key store. And if we scroll down, you'll have a bunch of networking and content delivery services as well. So you've got your CloudFront, which is your typical CDN. If you have a service or a static website somewhere and you kind of want to distribute it around the world at edge locations, you can use CloudFront. API Gateway is also another popular one. So for example, it works really well with Lambda. If you have a Lambda function with your code in there and you want to turn it into a URL endpoint, you can basically just hook it up with API Gateway. And then you'll have an HTTP endpoint that you can use to call that Lambda function. Now, even though there's hundreds of services here, those 4 or 5 ones that I mentioned are enough to get us started building something really basic. So to give you an idea of how all of these services could work together, let's take a look at a very simple example. Here's a simple to-do list application that I've built and hosted on AWS. I'm logged in as this user and I can add a task. And if I've completed one of the items, I can check it off the list. This is all saved to a database in the backend with my username associated. So even if I refresh the page, all of my to-do items will persist, even if I go to a different computer or access this page from my mobile phone. And because this is using a static front end and serverless functions for the API, I'm able to host this pretty much for free. Let me show you how that's done. Here's a simple architectural diagram for this app. So I want to have a static website that the user can visit, and I'll build that with React or Next.js. And then I want to have that website interact with a Python application via an API so that I can create and view my to-do list items. And I'll probably want those items saved into a database too. Now there's probably 100 different ways you can implement this, but here's how an AWS implementation might look. We can use S3 to store and host our static website. That will produce an endpoint that our user can visit, as you saw earlier. We'll put our Python script into an AWS Lambda function, which we can connect to an endpoint using API Gateway. And then the website on S3 can talk to that API endpoint. And every time our users interact with their to-do list, we'll call this API, run this Python function, and then update our database with that item. So this is one of the ways we can build this to-do list application. And the great thing about it is that by using the serverless architecture like S3, Lambda, and DynamoDB, you only pay for what you use. So that's why this is pretty much free until you start hitting huge amounts of traffic. I'm talking like maybe thousands or even tens of thousands of users per month. On that note, let's take a look at how pricing works on AWS. This is going to be something you'll want to pay a lot of attention to if you don't want to be surprised with a large bill at the end of the month. On AWS, you pay for what you use. For example, if you want to start a virtual server, you might want this 16 gigabyte instance here. And here the cost is 16 cents per hour that you use it. If you start one of these virtual instances and you leave it running for a day, it's going to cost $4. That's pretty straightforward, but you actually also have a lot of other services that have more complex pricing structures. For example, per gigabyte of data stored or per gigabyte of data transferred. This can get pretty complex. So if you turn on a lot of services without understanding how the pricing works, and then you forget to turn them off, then you might be surprised with a really big bill at the end of the month. That's why the first thing I recommend you do after creating your AWS account is to set up a pricing alert. In your AWS console, search for budget, and then click on AWS budgets. And then here, click create a new budget. And here it's already got a bunch of predefined templates you can use. And if you don't want to spend any money, then just use this zero spend budget. So you're going to get notified as soon as even 1 cent of expense hits your account. So this is perfect if you want to use AWS for free and you're not sure if you're going to accidentally turn on something expensive. Just create this budget and it's going to send you an email. And so you can go into your AWS account, see what's happening, and then turn it off before the bill starts to accumulate. Although AWS billing is quite complex, the flip side is that you can get a lot of value out of it if you use it efficiently. You could run an entire startup on it for quite cheap or even for free. This brings us to the next topic, the AWS Free Tier. This is great for anyone who wants to get started on AWS or for anyone who just wants to experiment. With the free tier, you basically have free access to a bunch of services and resources that are either always free up to a certain monthly usage limit, or a bunch of resources that are free for the first 12 months of creating your account. And if you go to this page, which I'll provide the link for in the description, you can scroll down and find all the different services that have this free tier along with the limits that they support before you start getting charged. So for instance, I'm looking at this EC2 compute and I can get 750 hours of hosting per month for free on EC2 using this particular type of instance. And I get this for free for the first 12 months. Or to use this other example, Amazon S3, I can store 5 gigabytes of items for free for the first 12 months as well. So again, some services have a free usage limit that resets each month, and that includes Lambda functions, DynamoDB, SQS, and CloudFront. So if you build something using these components and your usage per month is under the free tier limit, which usually is quite generous, then you're pretty much paying nothing to host that service. I recommend sticking with these ones because you can actually use them to build a working app that serves hundreds of thousands of requests per month before you even have to pay anything. On the other hand, you have some that are free for the first 12 months. And that includes EC2, S3 storage, and RDS, which is like a managed SQL database. So you can try them out too, but I really recommend sticking with the ones that are always going to be free. The exception here is S3. So even though it's in the 12-month free tier and not the always free tier, it's still your best option on AWS for storing any type of data. Even when it's out of the free tier, the pricing for S3 is still pretty reasonable. You pay something like $1 per month to store 50 gigabytes of data. Now, how do you actually use AWS? Well, here's 4 different ways you can use it. You can go to the website and just click around in the console. This is great for starting out, but not really the best way to do it at the end of the day, because you'd probably want to be automating a lot of that work, and you can't do it if you're clicking things in the browser. Next, you can also use a CLI from your terminal. It's great for debugging and doing one-off operations, and because it's a CLI, you can have some level of programmatic access to it, so you can automate it a little bit. But if your goal is to use AWS programmatically, like have something in your application code, talk to AWS, maybe put some items in a bucket or retrieve them, then there are SDKs available for all major programming languages, so that's what you could use. And finally, for advanced users, there's AWS CDK. This lets you write infrastructure as code. So if you've ever used Terraform, it's something like that. Let's take a look at each of these things. First, you're going to have to create an AWS account. Start by heading over to aws.amazon.com. You should see something like this. And in the top, click Create an AWS account. Enter an email and a name for your account, and then click Verify email address. Enter your verification code. Next, you have to choose a password for your account. Make sure you choose something that's really secure and that you don't reuse this password anywhere else. And then click Continue. On the next page, just fill this in with your personal information. And here I'm going to choose a personal account. Once that's all filled in, click Continue. On the next page, you'll have to enter your credit card information, but it doesn't mean that you're going to be charged. As we said earlier, you only pay for what you use. So if you set up your billing alerts, you can be extra sure that you don't accidentally turn on something that costs you money. Next, you'll have to do this identity verification. And on the last step, just stick with the free support plan. I don't think you'll need anything else at this stage. And then just click Complete Sign Up. At this point, you're pretty much done, and you should now be able to access your AWS console. So log in with your root user email address and your secure password. And this is how your console should look. Now, a concept that you need to be familiar with is that AWS is split up into a bunch of different regions. This is basically going to be the geographical location of the data centers that you will end up using. The closer it is to you and your users, the faster your service will be. Once you've created your account, you can select your region by clicking this tab here. And for me, it's chosen Sydney because that's the closest region to me, but browse through this list and choose whatever is closest to you. Or if you're not sure, just use US East 1. Now you can change this at any time. You can just simply click here and the page will reload for that region. But something to keep in mind is that any service and resource you create is going to be region specific. For example, I've changed over to this US East region, and if I go ahead and create an EC2 instance running in this region, this virtual server is physically going to be located in US East. So if I have that server running and I change back to my Sydney region, I won't see that instance any longer because I'm in a different region. I'd have to change back to the US 1 region where it's still running. So basically, each region will have its own separate set of resources. Having said that, there's actually some AWS services that are global and they're not tied to a specific AWS region. This includes things like CloudFront, which is the content delivery network, or Route 53, which is the DNS service. To use AWS from your computer or from an app, you also need to create an IAM user for that account. IAM is AWS's identity and access management system. It lets you specify who has access to what resources. And this is also one of the global resources that is not tied to a specific region. By default, AWS is very strict with security. It is always recommended to create users or roles with the bare minimum access required to do its job. And if you want to learn more, there's actually an entire page of security best practices that you can check out in the video description. But because we're still learning, let's create an admin account with complete access so that we can use it for our CLI and our SDK. Go back to your console and then search for IAM and click into IAM. In your dashboard, go to Users and click Create User and enter a username. And we can just click Next. And here I'm just going to click Attach Policies directly. And I'm going to search here for Administrator Access. So that's going to be this top one here. And click Tick to add it, and then click Next, and you should see that we're going to have this user with this name and this administrator access policy, which will let it do anything in our account, and then click Create User. Once a user is created, click on the username to go into it, and now we're going to create an access key, which is kind of like a password that we can give to things like our CLI or our SDK, and that will let it use this user to access our account. So click Create Access Key. Now on this page, AWS is trying to persuade us to use a different way to access our account, because access keys are basically a string that if somebody gets their hands on them, they will have access to your account. So the best practice is to use access through some other means. And you can actually read through a bunch of these recommendations here. So even though we're going to use the CLI and it's recommending us to do something else, we're still going to just go ahead, skip this, and create the access key anyways. But if you want to raise your security bar to the next level, I recommend maybe spending a moment to explore some of these other options. For now though, let's keep going. And here you can really enter anything, it doesn't really matter. And now your access key is created. You can see this notification at the top here. It says, this is the only time that the access key can be viewed or downloaded. You cannot recover it later. So if you ever lose this, you basically have to delete it and create a new key. And you can download the key as a CSV file, or you can click here to see your secret access key. And this is the key that you basically don't want anyone else to see. So keep this very, very secret. Also, another really common mistake I see some people make is that they accidentally commit their access keys in a file or as part of a config into their GitHub repository. And then it's public for the world to see, and somebody with a bunch of bots scanning GitHub files is going to find this key and then use it to access your AWS account. So also be really careful about putting access keys into version control. Try to avoid it entirely if you can. That also means not hard coding your keys into your program. So if you need it in your application, try to get it from something like an environment variable instead. Never ever hard code it. Now that you have your access key, let's take a look at how you can use the AWS CLI. The AWS CLI lets you interact with your AWS account directly from the terminal. You can use a command like this one to check the status of your resources or to do things like starting or stopping a virtual server. You can install it into your Python environment using this command. Once you have it, you can set up your CLI by using the AWS configure command. Next, just copy and paste the access key ID and the secret key ID that you created for your IAM user earlier. Next, you can choose which is going to be your default region. I'm using AP Southeast 2, which is Australia, but for most of you, you might probably want to use something like US East 1. And finally, you might ask about the default output format, and for that, I like to use JSON, so you can put JSON there as well. Now to check whether or not you've configured things properly, you can use this command to basically just do a sanity check with your credentials and see if it can reach your AWS account. If you've configured things properly and you run this command, you should be able to see an output like this. Now, anytime you use the AWS CLI from now on, it's going to default to this user and this region. So now with our AWS CLI configured, let's use it to create a resource. I might want to store some data in my AWS account, for example, images or videos. So let's create an S3 bucket to store that data. And here's the command you can use to create an S3 bucket with. I'm going to call this bucket pixegami sample bucket, but replace this name with something unique for you, because S3 bucket names are globally unique, so you won't be able to use the same name as somebody else. And once you run this command, it should create this bucket in the default region for your account. Now let's also use the CLI to list all of the available buckets in our account. And then you can see here that the bucket that we've just created should show up right there. You can also go and have a look at the bucket you've just created from the console as well. So go back to the console and then go to the search bar and search for S3, and then click on this S3 service page. And here you can see the actual bucket and you can click into it and you can even upload an object. Here I have a simple text file with this hello world message. Go to the file in your file explorer and you can just drag and drop it into this bucket. And now our file is there and we can close this page. Now by running that configuration on your AWS CLI, you've actually stored the credentials for your CLI to disk, and it's at a location like this. It might vary from different systems, but I'm using a Mac and this is where it's stored. So if you ever want to view those credentials or add new ones or update them, this is the file you can go and edit. This is an important detail because by having this set up, it's now universally accessible by other AWS tools on your computer, including the AWS SDK that we'll be looking at next. If you want to access your AWS resources from within an application's code, for example, if you want to put things or retrieve things from that S3 bucket we created earlier, then you can use an AWS SDK, which is a client library. And there's one for every major language. Let's use Python as an example. You can install it into your Python environment using this command. In Python, the AWS SDK is called Boto3. I'm not sure why, but that's what it's called. Once it's installed, you can import it into a Python file like this, and then you have access to an AWS client. And in this script, I'm creating an S3 client. I've supplied it with the name of my bucket. So if you want to run the script for yourself, make sure you replace this with your bucket's name. And here's the file that I copied in earlier. And I'm going to download this file to a temporary location on my computer, and then I'm going to print the contents of that file. And now I'm going to open my integrated terminal and run that command. And you can see here, it only takes a second and it just prints out this hello world message that we saved to our S3 bucket. Because we've set up the credentials with the CLI, when we run this file on this computer, the SDK knows where to find those credentials and it's able to access our account. However, AWS actually has an order of precedence when it looks for credentials. So if we want the SDK to use a different user or even a different account, we can override the default by just putting it into our environment variables. And if these environment variables exist and have an access key, then the SDK will respect that first before looking for the credentials elsewhere. You can learn more about this by looking up the credential provider chain on AWS. Now let's talk about our last tool for today, which is going to be the AWS CDK. This stands for Cloud Development Kit, and it lets you write and deploy your AWS infrastructure using code. By infrastructure, I'm talking about all the different resources used in this app along with their configuration. So in this case, we can create an S3 bucket, the Lambda function, the DynamoDB database, and the API gateway, and then we can wire up how it all talks to each other. We can do all of that with code using AWS CDK. This is great because now you can essentially program your infrastructure in a language that you're familiar with. CDK supports TypeScript, Python, Java, and C#. And this code can also be version controlled with Git. So if you make an infrastructure mistake or something goes wrong, you can look back at your previous commits and figure out which version was working properly. To install CDK, you're first going to need Node.js. So if you don't have that already, then head over to nodejs.org and then read the instructions on how you can download and install it. Once it is installed, run this npm command to install CDK globally. And then you can run this command to check whether or not your installation was successful. Now, if you want to create a new CDK project, go to an empty directory and then use this command. Here, you can specify the language you want to use. So as I mentioned earlier, you can use TypeScript, Python, Java, or C#. I recommend TypeScript even though I'm primarily a Python user. That's because CDK is natively built with TypeScript. So I find that things like documentation, community examples, and IDE support are generally better with TypeScript. Once the command finishes, your project should be initialized with a bunch of files. So this is your CDK project. And you can start writing your infrastructure code in this TypeScript file over here. So now let's look at how we can actually create an S3 bucket like we did earlier, but this time using the CDK instead. First, we'll need to import the S3 construct like this. And this is how we can create the actual S3 bucket. And this is going to be the logical name for the resource, but you're going to see that this actually doesn't become the bucket name itself. The real bucket name is going to be a completely randomly generated string, which is really good for us because as we talked about earlier, S3 bucket names are globally unique. So you don't want names that can potentially clash with others. Now save this file and let's see how we can deploy it. Before we can deploy the bucket, we have to bootstrap CDK. This will create a one-off set of resources that CDK needs behind the scenes. And it's something you only have to do once per account per region. You can do it using this command. Now after that's done, you can deploy your app. We'll do that using this CDK deploy command. And after about 30 seconds, this should be done as well. And if you use the CLI to list the buckets in our account again, you'll see that our original bucket that we created by hand is there, but we also have this new bucket that we've created with the CDK stack. And this bucket here was the one that CDK created for itself when we bootstrapped it. So now we have 3 buckets in our account. Now I want to show you something else. Go into your AWS console and then type in CloudFormation and then click on the CloudFormation service. Here you're going to see 2 apps. The CDK toolkit, again, it was the thing that CDK created part of bootstrapping. But then you also see this new stack that should have the name of the folder that you created your CDK app in. So this is actually the app that we deployed just then using the CDK. It kind of bundles it up into something called a CloudFormation stack, which you can sort of think as a logical grouping of a bunch of AWS resources. And if you click into the stack, you can see a bunch of information like when it was created or updated. And you can click on this resources tab to see all the actual AWS resources created as part of this stack. Anytime you want to make changes to this app, if you want to add resources or change how resources are configured, you can just basically make the changes in your CDK code and then run that CDK deploy command. And you should see that this CloudFormation stack gets updated as well. Now, if you're done with experimenting or you don't want to use your stack anymore, you can just delete the entire application by just clicking delete over here on the stack. And you might have to refresh the page, but then eventually the stack should be deleted. Now, the stack deletion might fail if you have S3 buckets with data inside them or tables with data inside them, because by default, AWS is paranoid about deleting anything that might have data that's super important for you or your business. In those cases, the stack deletion itself will fail, and what you'll have to do is just go to those individual databases or S3 buckets and manually delete them and confirm that, hey, you're okay to remove this data, because you're never going to get it back after you delete them. So now that we've gone over the basics of AWS and then looked at how to create and use some of these resources, let's go back to the beginning and take another look at that app that I showed you at the start of the video to see how it was configured. The app was a to-do list application with a static Next.js frontend and a Python backend. This is the source code for the app. I've configured the entire app with CDK, so you can see here this is the stack for the entire app. When I build the Next.js frontend, I have it exported into this out folder here as a static website. So I have this index.html. Back in the CDK, I've then configured this S3 bucket to use this index.html as the page to display. I've also given it public access here so anybody can visit this site. Because remember, by default, AWS is secure. So if we don't give it public access, no one will be able to access this. The Python API is just this one file here, which I've created with Fast API. And this Python app is hosted on a serverless Lambda function, which is hooked up to this DynamoDB table so that it can read and write items to the table when we use it. There's also a handy helper function here to make the Lambda function publicly accessible through a URL. Now, all these services are on the free tier, apart from S3, but that's still extremely cheap. So this entire setup is actually completely free for me to host, at least until it hits thousands of users per month. You can also go to this GitHub link if you want to take a closer look at the source code for this project. In the repo, you'll find all the code, including the Next.js frontend, the Python server, and the CDK code as well. Once you've learned the basic building blocks of AWS, you can start putting them together to make more complex applications. So here's a couple of reference AWS architecture diagrams that show you how to build a larger application. Here's an example for something like a multiplayer game server. So if you want to have a Counter-Strike server or maybe something like League of Legends, here's how you can build it. There's a Lambda function connected to your database, and you can also use GameLift for the queuing and matchmaking system. And here you have a fleet of servers to run the actual game logic itself. Here's another example. This is a diagram for an AI stock trading agent. Again, you might already start to recognize some of the basic components like this S3 bucket for storage, DynamoDB tables, and Lambda functions. You also have more exotic components here like SageMaker that will train and run the AI models on the data. That's going to be all for today. If you enjoyed this video and you want to learn more about building on AWS, then subscribe to my channel and let me know in the comments what type of projects you'd like to see next. Otherwise, I hope you found this useful and thank you for watching.